Okay, so for this one we are also simplifying, and we'll see things in this form in the next chapter when we do quadratics and we do quadratic formula. This is often the shape of the answer, so what this one is doing is kind of giving a little preview on the root part and how we're going to have to simplify those for chapter 5. So what we do here is the same old simplifying for this root 50 that we've been doing all along. So let me just slip over here and do that part. So square root of 50, thinking of my perfect squares, 25 and 2 is what I'm going to want to think of that as. So I'm thinking of it this way, square root of 25 times 2, and square root of 25 brings out our 5, and then there's our root 2. So now let me rewrite this, negative 15 plus 5 root 2 for that 50 over 5. So what this really is, this 5 belongs to the 15 and the 5 root 2 equally. Let me write something over here to show you what I mean by that. Let's say I had 1/7 plus 2/7. So we know that's going to be 3/7, but I can write that as 1 plus 2 over 7 before I stop off, and because these are like terms, I can combine them at 3/7. So if a fraction has the same denominator, I can write it as the numerator adding or subtracting as needed over that denominator. So this way or this way. So that's what I'm going to do here. For this is something we can't combine because this has that root 2 attached and this doesn't, so those aren't like terms. That's as far as I can take that. But I'm going to rewrite this like this to show you the canceling, and then I'll show you an easier way to do it after that. But this is the how come the other thing's going to work. Okay, so now we can see hopefully that this 5 reduces. So 5 goes into 15, negative 15, or just like negative 15 divided by 5 would leave a negative 3 right there. And this 5 times root 2 divided by 5, those reduce the same way as if I had like 5x over 5, that becomes 1x. So I can reduce those, and that just becomes like invisible 1 root 2, the same way that we probably wouldn't write a 1x there, we probably wouldn't write a 1 right there. But if it helps you to see what's happening, 5 over 5 is making that 1. And then again, generally, we would just have it as a plain root 2. So an easier way than to write all that, this bit right here, out. Actually, let me grab that eraser again. I'm going to just bring this over right here. So the way that I think of this is if there's a number that divides in to all 3 of those numbers, then I can reduce it out. And that's because right here 5 goes into 15, so that's going to reduce, and 5 goes into 5, so that's going to reduce. So an easy way to do it from right here is just all of these are divisible by 5, so I'm going to divide them all by 5. So in that case, 5 goes into 15 3 times, 5 goes into 5 once, 5 goes into 5 once. And so then there's my negative 3 plus 1 root 2 over 1. But again, we don't write those ones at all. So this would just be negative 3 plus root 2, because those happen to be ones. If these were other numbers, 2s and 5s or whatever, they would stick around. So this is kind of how I like to think of that, rather than doing all this, but this is the how come that works. Actually, let me just do one more of those. I'm just going to make one up real quick. Let's say just the reduce part at the end. So let's say I had 14 minus 4 root 3 over 6. So if I do the same idea, 14, 4, and 6, those are all divisible by 2. And so this would be 7, 2 would go into there twice, 2 would go into there 3 times. So then my reduced form, my answer would be 7 minus 2 root 3 over 3. So there it is, kind of one more time. Again, I could have written that out and gotten that 7/3 over 2/3 that we're seeing right there, that's just a lot cleaner and easier to me.